Hello viewers and my dear students. Welcome to session 2, that is problem 2 demo on CNC manual part programming for a turning profile using Denford Fanuc turning simulation software. These are video tutorials on CNC manual part programming of turning exercises using Denford Fanuc turning simulation software. As I've told you, this is session 2. In session 1, I've completely explained how the manual part programming can be done for this profile. Okay, it has been completely explained using G71 and G70 cycle. G71, as you know, it is a multiple turning, rough turning cycle, and G70 is the finishing cycle. This I've already explained. Now, and also in the first session, I've also explained what is planning and operation sheet. At least here, you have only rough and finish turning operations. And for the rough turning operations, I've taken 50 mm per minute as the feed, and for finish turning, I've taken 30 mm per minute as the feed, and the speed is 1200 for both roughing and finishing. Now, before I'll start with using the Fanuc turning simulation software, how to do the simulation using Fanuc turning simulation software, I'll just explain very fast how exactly this was done. See here, this is the profile given. Once this profile is given, you have to get the coordinates of A, B, C, D, E, F, G, H, I, J in terms of X and Z. As you know, this is perpendicular to the axis is X and parallel to along the axis is Z. Now, as you know here, this X is at A, X is 8 and Z is 0. At B, X is 8 and Z is minus 8 in that way. Anyway, I'll explain this. See here, the manual part programming is done this way. First, looking at the design, the maximum diameter is 48 here and the length is around 80. That is 8 plus 6, 14, 28, 38, 48, 58, 61, 78, 80. That is why I have taken the billet size, the workpiece size to be little more than 48, that is 50, and the length to be little more than 80, so that it is 100. Okay, then G21, G98 and all that I have given. It is all basic, the inputs what you give, that is basic initial standard setting, metric unit and feet per minute and all that. And G28 U0, W0, it will take you to the home position and changing the tool to 1 and changing the speed to 1200 and all that. Now, this is where you have to be careful because this is a standard question what will be asked and all that. See here, the home position of the tool will always be here. Okay, from the home position to the tool entry point, it comes rapidly. G00 is rapid traverse. From home position, it comes rapidly to this tool entry point, that is X50 Z2. That is X is 50 you have already taken, that is billet size, and Z2 means it is Z0 here minus here. Z2 means you are in the same position, it is not hitting the workpiece, it is 2 mm away from the workpiece. Okay, X50 Z2, and as you know N10, N20, N30 and all that block numbers are sequence numbers. You are writing it here. After some time you need not write, I'll tell you how exactly it can be managed. Okay, and very carefully you should know G71 is the rough turning cycle. G71, U1 is the depth of cut, R1 is the retract distance. After every cut, the diametrical reduction will be 2 mm and the tool moves back by 1 mm. That is the meaning of this. Okay, now you see here G71, P80, Q170, U.5, W.5, F50. This you should know very well. That means between the block numbers N80 and N170, you have the program for this particular profile. Okay, now you see here N80 to N170, it is here. Between N80 and N170, you have the profile, that is the profile in terms of X and Z, what has been fed as a manual part programming. See here N80, G at A, G01, X8, at B, G01, X8, Z minus 8, and at C it is X12 Z minus 14, that is at C X12 Z minus 20, that is minus 14, in that way. That is here and all that it is G01 linear interpolation. That means what you should know it is between 80 and 170, whatever the program you have written here, it is all under your control because you are given the feed as 50, the tool moves at a distance of 50 mm per minute. Okay, now I have clearly given here that is G01X8 tool moves to point A, G01X8 Z minus 8 tool moves to point B, G01X12 Z minus 14 tool moves to point C. In that way, I have given clearly. You please go through this which has already been covered. Okay, once 170 you have completed, that means tool moves to point J. Okay, now it has come to this position. Now, as I have told you, it is U.5, W.5 means it is rough turning. Since it is rough turning, you will have an allowance of 0.5 on X and 0.5 on Z also. That means this 8 will be actually 0.5 here, 0.5 here means after rough turning it will be 9 here. Okay, and even here after rough turning it will be 29 here. Okay, after rough turning it is 45, after rough turning it is 49, and even here it is 8, it will not, after rough turning it will be 7.5, and at this point it is not 14, it will be 13.5. In that way it will be that particular the extra allowance of 0.5 will be removed during finishing. For finishing we just use this cycle G70 P80 Q170, that means the between the block numbers N80 and N70 you do the finish turning at a feed of 30 mm. If you just give this, the same tool will come and it removes only the extra allowance that is left on X and Z, and it becomes finally the exact profile what you wanted with utmost accuracy. 8 means it will be exactly 8, removing allowances and all that. Then the tool goes to home position and all that. M05 stops the spindle, M30 program stops and rewind. Okay, now I'll show you. Now I'll show you how exactly this will be fed using Fanuc turning simulation software. How it is operated using that. Now the idea is that whatever program we have done, we have to enter in Fanuc turning simulation software. For that, I'll tell you how exactly you have to do. You go to docs box. Then mount Z mount D first, first drive D should be mounted on the local directory D, then D colon okay, then change directly to lathe, then fanucl.exe you do. Okay, now once you do this, as you see here, you have this screen obtained. Okay, you have this screen obtained. Now what you do is function, that is F3 you press. F3 you press, file name for load. Actually, I have loaded this program, whatever I've just now explained, I've already loaded in terms of 0 turn bg.fnc. Just load this. See here, this program is the same thing. What I've just now told you, this is G01X8, G01X8, Z-8, everything. Whatever I have just now explained, you enter it in this Fanuc turning simulation software. Okay, this is the Fanuc turning simulation software. You just have to enter it here. Once you enter it here, once you enter everything here, take the cursor to the top, then function F9 you press. First you check for the syntax. If you are written correctly, your CNC program is okay, that symbol it gives. That information it gives. Then again function F9 and you press dry run. Okay, that means it will go to the, as you see here, X50 Z100. No, it is X50 Z100. It clearly shows That means whatever the billet size you assume, that will be simulated here. X50, Z100 in that way. Then once you do this function, okay, then you see this run program you do. Run program if you do, you see here the tool is coming here. You keep observing every time it reduces by 2 mm. See here 48, now it is 46 because in that is cut increment is 1 mm. Diametrically it reduces by 2 mm. You keep observing here. This is the thing. At the same time, you should be observing the alliances at the later stages. It will be removing. It will be having alliance of 0.5 on X and 0.5 on Z also. Okay. Now you keep observing. This is a simulation what is being done, and it will exactly match with the manual part programming what exactly you have done. See carefully. Now see here 38, 28, 26, 24. See here, because cut increment is 1 mm, that is why diametrically it is reducing by 2 mm. Okay. Now 18, 16, 14, 12, 10. Now you see here 8.5, 12.5, 28.5, 44.5 and 48.5. That clearly says that is the alliance left on X. Now during finish turning, those things are removed here. Okay. Now it exactly becomes the profile what you wanted. Now the simulation is done. Okay. Once the simulation is done, you can just see a function F9. You can see the 3D view also of this. Okay, 3D view of this also. Okay, now this is the way it is done. Now I have done the programming correct and the simulation is correct, and you have observed that the alliances being removed in a perfect manner and all that. In that way, you are more or less certain that if this program is fed, you can get it, you get the same component on the CNC. This is in fact the same screen what you find in many of the Fanuc turning simulation softwares. Also, Fanuc turning simulation, Fanuc machines. The same screen will be there. You are entering in the same way, and you are simulating also in the same way, and finally you are getting the component in the same machine. Okay. Now, as you see here, this is function F10. If you see, you can see here simulate only also you can do. That means in the entire scene you can see the simulation. Did you follow? In the entire scene you can see the simulation. That is why function F9 run program means you can see the simulation in the entire screen. Okay. Now as you see here, this is in the entire screen the simulation is being done. This is the thing. Now as you are aware, in the entire screen, since it is being done, it is running slowly, and also here you will have a good chance of viewing what exactly is happening, and you can clearly see the alliances being left on X and Z always. Okay. Now as you see here, since the diameter cut increment is 1 mm, always it will be removing 2 mm at one stretch. See here, it is X42. Next, X40, because the cut increment is 1 mm. Okay, in this way also, that is complete screen simulation also, that is full simulation. In this way also you can do, or you can do partly, that is editing as well as the simulation also you can do. Okay, these are all the options left. Now as you see here, you can you are getting the same thing again. If you want to stop this, just put escape button. CNC run is aborted, and you can do F9, F10. You can just say quit, and if you want to save the file, you go to CNC files, you save it here, save as your number and all that. 02 turn BG are given. You can give some name, 05 turn BG in that way. You can give the name in that way. Okay. Now we have come to the end of session 2, problem 2. Okay, problem 2, end of session 2 of problem 2. Okay, thank you very much, viewers.